Hello, and welcome back to the Microservice Architecture and Design Pattern series. In microservice system, services rarely work alone. They constantly talk to each other. An order service talks to payment service, a payment service may talk to inventory, and inventory may talk to shipping. But there is a fundamental question we often ignore. How does one service find another service? Let's take a simple online shopping cart example. We have an order service and we have a payment service. When an order is placed, order service must call the payment service. In a monolithic service, this is trivial, but in microservices, things are different. Payment service can scale up, can scale down, can move to another machine, can restart with a new IP address, can get installed on a new Kubernetes cluster. So hardcoding host names or IP addresses is not an option because in a dynamic system, addresses can constantly change. Now this creates a serious problem. Service discovery pattern helps us to solve this problem. Service discovery provides a way for services to dynamically locate each other at runtime. Instead of hard coding addresses, services ask a central component, where is the payment service right now? And the central component is called as Service Registry. Here is how it works. When the order service or payment service starts, it registers itself with the Service Registry. It provides its name, its network address, and it periodically provides its health status. Now, when the order service needs to make a payment, it queries the service registry and asks for available payment service instance. The registry responds with a healthy instance and its location. The registry responds with the network address. The order service then makes the actual call. There's no hard coding of addresses, no assumptions, no manual configuration updates. The key idea is simple. Services don't know where other services live. They only know what services they need. Service discovery bridges that gap, and that is what makes microservices scalable, resilient, and dynamic. Let's implement service discovery using ASP.NET Web APIs in C# language. I have a blank solution created called Service Discovery in Visual Studio. Let's add new ASP.NET Web API project to this solution. Let's call it as Service Registry. We don't need HTTPS for now. Let's click create. Now our business microservices will make call to this service registry for registration and unregistration. Now let's represent the registration request in a record type. Let's call it as service registration request. Let's add the class. We'll make it as a sealed record. It will have a property name and location so that the incoming service registration request from our business microservice will have the name of the service and the location or the network address of the service. The service registry service should store the incoming requests in a dictionary. Let's add new class and call it as registry dictionary. Now in real world application, this could be a database, but for demo purpose, we'll simply store the service registration requests in a local dictionary. We'll add a private dictionary so that we can store the incoming service registration requests locally. We'll also expose register and unregister methods so that the dictionary can be populated by the incoming service registration requests. We'll also add a get method so that we can pass in the name of the service and get the location or the network address of the service. Let's add few endpoints to this service registry microservice so that the business services can register themselves, unregister themselves, or send a heartbeat or get the location of registered microservices. Let's add a class. I like to keep my program.cs file clean, so I always use the extension methods to add the endpoints. Let's add a new class. Let's call it as endpoint route builder extensions. Let us add register routes method to this class. Now, this will be an extension method on the I endpoint route builder interface. We'll use this method to register various routes. Now let's add the register heartbeat route, register location route, and register registration routes methods to this class shortly, and we'll return the app. Now since this is a static method, let's add the register heartbeat route method first. This method will be used to register the endpoint for sending heartbeats. The business microservices will periodically let us know our central registry service so that these services can keep track of their health and network addresses. Let's add an endpoint called heartbeat. The business microservice will send their name to this endpoint and will simply log the incoming request to console for now and will return an OK result. Let's implement the register location route method. Now this method will be used to register a location route. This location route will be used to get the location of the registered microservice. We'll accept the service name in the input from route and we'll return OK result containing the location of the service. Let us add the main register registration routes method. Now this method will be used to register the register and unregister endpoints in this microservice. First, let's implement the register endpoint. We'll accept the service registration request from the incoming business microservice. We'll log the current date time to the console and we'll add the incoming service to the registry dictionary. We'll also return the accepted result. Let's implement the unregistered service. Now this endpoint will be called by the business microservices while stopping. We'll also accept the service registration request in the input. We'll log the current date time to the console and we'll simply unregister the service from the service registry dictionary. We'll also return the accepted result and then we'll return the app. Now in our program.cs file, let's add and register the required services. So first we'll add HTTP client and then we'll add a singleton instance of the registry dictionary. Now in a real world application, this could be a database, so you can register your DB context here and we'll register various routes. Now since these methods are not recognized, let's add the required namespaces. Now every business microservice will have to make this register and unregister call on startup and on stopping. A lot of this code will be duplicated in every business microservice. Instead of that, let's put this in a common shared location called as a class library. Okay, let's create a class library project in this solution and let's call it as service registry lib. This class library project can be consumed as a NuGet by the business microservices. Let's add an interface to this project called as iService client. Now this iService client interface will have methods to register, unregister, get the location by name, and to send a heartbeat, these methods. Let's rename the file to suit the interface. Let's implement this iService client interface. Let's add a class and let's call it as service client. Let's make it public and implement the iService client interface. Let's add a constructor to this service client. We'll inject iHTTP client factory and iConfiguration interface into this constructor. Let's add HTTP client and a private read-only field for configuration. We'll read the service registry location from application configuration. Now, the business microservices need to know only the location of service registry. We'll create an HTTP client and set its base address to the URI of the service registry. Then, we'll implement the iService client interface methods. Let's first implement the getLocation method. We'll call the service registry location API and pass the service name. We'll get the network address or the location of the service. Next, we'll implement the register and unregister methods. The register method will be called by the business microservice during startup. We'll create a service registration request object and we'll call the register endpoint of the service registry. Similarly, we'll call the unregister method during stopping time. We'll create a service registration request and call the unregister endpoint of the service registry. Let's implement the heartbeat method as well. Now, business microservice will get the name of the service from configuration and call the heartbeat endpoint with its name. Now, every microservice will need to read the service name and its location from configuration. So let's add a iServiceInfo resolver interface to this library project. This interface will read the configuration for the business microservice name and location. Let's make it public and add a couple of methods. The first method would be to get the service name, and the second method would be to get the service location. Let's add new class service info resolver, which will implement this iService info resolver interface. Let's inject the iConfiguration interface into this constructor. We'll use this iConfiguration to read the application configuration file. We'll implement the iService info resolver methods such as get service location, which will read the service location from configuration, and we'll also implement the get service name method, which will read the service name from configuration and return the same. Let's move the type to its own file. The business microservices will periodically send heartbeat to this service registry. We could use a heartbeat service as a background service. This service will periodically send heartbeats to the service registry to ensure that the service is healthy. Let's add a class called as heartbeat service. Let's implement the service class. Let's make it public. Let's add a constructor to this hybrid service. We'll inject iService client and iConfiguration into the constructor. We'll implement the execute async method from the background service class. We'll read the heartbeat rate from application configuration and try to parse it as an integer. A business microservice will send the heartbeat until cancellation is requested. So we'll use the service client send heartbeat method to send the heartbeat. Based on the configuration, we'll wait for certain number of seconds. Now this class library will be installed as NuGet in the business microservices. The business microservices need to send registration request on start and unregistration request on stop. Now this is a repeated code. So let's put it in an extension method and then we can reuse it in the business microservices. Let's add a class called host application lifetime extensions. Let's make it public. Now we need to add registration and unregistration on start and stop events of the application. So we need to add extension methods on the I application builder interface, which exposes the lifetime object. So let's add an extension method on the I application builder. We can get the lifetime object using the application services get required service I host application lifetime interface. Now, once we get the lifetime object, we can call the onStart and onStop methods, which we will implement shortly, and return the lifetime. So let's first implement the onStart method. The onStart method will be called when the business microservice is starting up. Let's get the required service for iService client, iService info resolver, and the service name and the service location. Now on the lifetime object, we can get this application started event and call the register method to make a call to the service registry to register the current service. We can return the lifetime object. Similarly, on stop, we can call the application stopped event and register the unregister method of the service client and return the lifetime. Let's bring in the required namespaces. Let's add a couple of business microservices to this solution. Let's call the service as payment service. For simplicity, we'll use ASP.NET Web API project with minimal APIs. We don't need HTTPS for now. In the payment service, let's add a reference of the class library project. Let's add the required services. So we'll add HTTP client, we'll add the service client, we'll add the service info resolver, and add the heartbeat service as a hosted service. Then we can register the lifetime events for onStart and onStart events. Let's add a sample endpoint called as pay. This will simply log the amount to the console and return accepted response. Let's add another business microservice to this solution and let's call it as order service. Again, we'll use ASP.NET Core Web API for this demo application and let's create it. We don't need HTTPS for now. Let's add the class library project reference in this order service as well. In a real world application, this could be a NuGet published to nuget.org. Let's add the required services in this order service program.cs file as well. First, we'll add HTTP client, a singleton of service client to communicate with the service registry, a singleton of info resolver, and a background service for heartbeat service. Then we'll register the lifetime events. We'll add a method to register the routes related to this order microservice. Let's add a class to implement this register routes method. So in order service, let's add new class and call it as endpoint route builder extensions. I like to keep my program.cs file clean, so that's why I move the routes registration to a separate extension methods. Let's implement the register routes method. This will be an extension method on the iEndpoint route builder interface. Let's add a private static method to register the order microservice related app routes. Let's add a route for order, and then we'll get the ID from the URL and amount as well from the path. This is just a sample application. It doesn't have to be this kind of URL. It could be any endpoint. The key here is we want to make use of the service client and make a call to the payment service without knowing where the payment service is located. Let's inject the required services. Now using service client, we'll get the location of the payment service. We'll create an HTTP client, get its base address, and make a call to the payment service. Once the payment is successful, we'll return the accepted response. Now here the key is order service doesn't know the location of payment service. It only knows to make call to the service client with the name. It doesn't know the network address or actual address or URL of the payment service. Let's bring in the required using statements. Let's add the required configurations in the business microservice. Now let's go to order service app settings.json and add a section for service discovery. We'll add the current name of the service as order service and the location of the current service, that is order service, as this URL. We'll add the heartbeat rate and we'll also add the service registry location URL. Similarly, in payment service, we'll open the app settings file and add the required configuration. Let's add the service discovery section with service name as payment service, location where the payment service will be running, heartbeat rate, and the service registry location. Let's jump to the demo. I've opened the service registry, payment service, and order service in terminal window. Let's run the service registry first. Service registry is up and running on this port. Let's run the payment service. As soon as the payment service starts, it will register itself with the service registry. Similarly, let's start the order service as well. As soon as the order service starts, it will also register itself with the service registry. Now let's make call to the order microservice pay endpoint using these route values. Now once we call the order endpoint, it should discover where the payment service is and send the request accordingly. Let's make the call and we receive accepted request. On the order service logs, we can see we have started processing the request for payment. And on the payment service, we can see we have received a request to pay the required amount. Let's check if the services are getting unregistered on stopping. I'll press Ctrl C to stop the payment service. As soon as I stop the payment service, we get an unregistering payment service log on the service registry. We'll also stop the order service and we get the unregistering order service log on the service registry console. This is how we can implement the service discovery pattern. Now new business microservices can get added. New instances of those services can be created based on the load, or the services can be scaled up using multiple pods, but the consuming services don't have to worry about the network addresses of other business microservices. Our microservice will talk only to the service registry. New services can be added or scaled up or horizontally, doesn't matter. This is how we can implement the service discovery pattern. This pattern is a foundational building block of any scalable microservice architecture. By removing hard-coded service locations and introducing dynamic discovery through a service registry, services like order, payment, shipping can evolve, scale, and fail independently. This pattern enables resilience in highly dynamic environments where instances come and go continuously, and ensures that service to service communication remains reliable without tight coupling. In practice, service discovery is not optional. It is what makes microservices truly cloud native. In real world application, you can use third party services such as Consul to implement the service registry. Now, this was a very naive implementation of service registry using ASP.NET Web APIs. If you liked the video, please give a thumbs up or leave a comment if you have any suggestions. Please do check out other videos in this series regarding microservices design patterns. Thank you for watching.